Now that we have a good understanding of the problem, we have to find a solution to make sure that attackers won't be able to change the stream name here. So the solution that was found in the TurboRails library is actually to sign the stream name to prevent attackers from being able to tamper with stream names that are here in the HTML. So in this video, we're going to explain precisely what signing is and how it works in the Ruby on Rails framework. And in the next video, we will actually implement it in our TurboClone. So in order to sign strings in Ruby on Rails, we have this active support message verifier object that is actually used to sign cookies, for example. And its main responsibility is to generate and verify messages which are signed to prevent tampering. So in this video, we're going to explain clearly how it works and what it means. And to do this, we're going to go in the Rails console. And in the Rails console, we are going to create a new message verifier that we're going to store in a verifier variable. And the only argument it has to take is a secret key. So once we create our verifier variable, we can see that we are here with the message verifier instance. And this instance has multiple instance variables, and we're going to have a closer look at all of them. So the first one is digest here, and it's equal by default to SHA-1, which is the hash algorithm that in combination with the secret key will generate the signature. Don't worry, we'll have a look at what the signature looks like a bit later in the video. Then we have three instance variables here that we are going to ignore. So the onRotation and rotations instance variables are used to rotate the secret keys, but we won't need to do it in this video. And then there's another instance variable called options that we are not going to use either because we won't have any options to our verifier. And the last instance variable is actually quite interesting. It's the serializer instance variable, which by default is equal to Marshall. So if you don't know what a serializer is, basically the responsibility of a serializer is to do two things. The first one is to be able to convert an object into a string, and the second one is to be able to convert back this string into the original object. So there are multiple serializers in the Rails and the Ruby ecosystem in general. So we're going to have fun with the Marshall serializer to make sure that we understand what that means. So let's take our first article, for example. And what Marshall is able to do is that it's able to convert this article into a string, and then the string generated back into the article. So to do this, like every other serializer, it has two methods. The dump method is responsible for converting the object into a string, and then the load method is responsible for converting the string back into an object. So let's do this. We are going to call the Marshall.dump method on the article to converting into a string. I'm just going to store this string into a variable. And now what we can say is Marshall load. So that's the reverse process to convert back this string into a Ruby object. So that works as expected, but the Marshall serializer is a bit complicated. And in our case, what we want to do is simply to be able to convert strings into signed strings. So the serializer that we're going to use is a much more simple serializer, that is the JSON serializer. So the JSON serializer works exactly the same way, and actually you may have used it in some of your applications. So what it does, it converts strings or hashes into strings and then back into strings or hashes. So for example, if I do this, then the JSON.dump is going to convert a hash into a string, and I can do the reverse with the load method. So this works as expected, and this is why for our verifier we're going to use the simple JSON serializer. So serializer JSON, like this. And now if I have a look at my verifier, we can see that the serializer is JSON. So let's learn how to use the verifier. So let's imagine that we want to generate a signed string based on this initial article string here. So what we would do is use the verifier and call the generate method with the article string. That way, the verifier is going to generate some kind of gibberish that we're going to store into the signed string variable here. And we can do the reverse process to check that this signed string is actually meaningful to us. So we can do this by calling the verifier verify and then the signed string, and as we can see, we get back our article string that was passed in the first place. So there is also a verify method here that does exactly the same thing. The main difference is that if the verified method receives a random string, it's going to return nil, but the verify method will raise an active support message verifier invalid signature. So this is the only thing that we have to know to use the active support message verifier object, but we are going to go a bit deeper in this video to clearly understand what a signed string is, and if we were an attacker, how we would try and fail to tamper with the signed string. So let's clear this and have a look at our signed string. So as we can probably guess, the signed string is actually divided in two. The first part of the signed string, we are going to call it the payload, and as we are going to see, it's actually possible to get back to the original articles string that we passed. And the second part of the signed string, that's after those two dashes here, is what we call the signature, and this signature is generated thanks to the secret key and hash algorithm that was SHA-1 as we saw at the beginning of this video, and this is what makes it really hard to tamper with the payload here. So let's have a look. Let's imagine that we wanted to try to tamper with this signed string here. So the first thing we might want to do is to have a look at what is inside this payload here. So to do this, what we could do is call base64 strict decode 64 and pass it the first part of the string here. And this will give us the articles string. So now let's imagine that we wanted to try to tamper with the signed string and change this articles here to messages, as we did in the previous video. So what we might try to do is to call base64 strict encode 64, and then instead of passing articles here, we would pass messages, and then we would try to create a tempered string that would be equal to this, so messages as a first part, and then we might try to append the signature that was used for the article string. So this is our temper string, and what we might try to do then is to have this string verified. So we are going to call the verifier verify method with the tempered string. And as we can see, it raises an active support message verifier invalid signature. And this is because the signature is unique for each payload that was generated. So for example, if I call verifier generate with articles, I will get a different signature that if I call verifier generate with messages. As we can see, the signature here is not the same, and this way active support message verifier is able to tell if this string here was tampered with, and if that's the case, it will reject it. So this is what we're going to use in the next video to implement security. What we're going to do is that we're going to sign the stream names here, and each time we try to connect to the TurboClone Streams channel, we will check if the signed stream name is a valid signed string. If it is, we will allow the connection, and if it isn't, we will reject it. So this is how the security works by default in Turbo Rails, and we are going to implement it in the next video.